Okay, so we've looked at a very simplistic example of multicollinearity. Let's think about the idea in a more realistic setting. So we're going to look at the best value colleges data set. This is the version from 2018, and it's got a bunch of different colleges and different statistics about them. So what percent of people are admitted out of those who apply? What's the 4-year graduation rate? That's a percent. Total cost per year for in-state and out-of-state students, and then the average salary of its graduates. So these are 100 colleges that were ranked as the best in terms of value. You can see University of Georgia is here, number 12. So let's say that we were interested in predicting how much people are going to make when they get out of school. So we're predicting average salary. That's our response variable. We could consider a couple of different simple linear regression models. Each of these has only one predictor in it. So if we just use admittance rate, that explains 22% of the variability in average salary, highly significant, doesn't seem to be due to chance. Total out-of-state cost, that explains 35% of the variability, and total in-state cost explains 25%. So you can see all of these are significant, which means it's very unlikely that these were due to chance alone. Okay, so what would happen if we put these together into a multiple regression model? So I'm going to take admittance percentage and out-of-state cost and use both of those as predictors of average salary. What do you think the R-squared value would be for that model? So a lot of times the first thing that comes to people's mind is just the idea of adding up the R-squareds, right? So if you have 22% explained by admittance rate and 35% explained by out-of-state costs, then maybe it would be 57% explained by the model that includes both. So let's try it in R and see what happens. So I've already run my 3 simple regression models. Now I'm going to look at the first multiple regression model. This one's using admittance rate and total cost per year out of state. So I can run that model and then take a look at the summary. And I see that my R-squared here is 0.4597. Okay, so R-squared equals 0.4597. That's less than if we had just added up the R-squared values. So that means there must be some redundant information. In other words, there must be some association between these two variables. There must be some association between admittance percentage and out-of-state cost. So before we look at the next one, what do you think will happen in this next model? Pause the video and predict what do you think the R-squared will be when we add in-state cost to the model we were just working with. Here we're using a multiple regression model that has admittance rate, out-of-state cost, and in-state cost. And look, our multiple R-squared comes out to be 0.4597. R-squared is 0.4597. That's basically the same as before, all the way out to 4 decimal places. That's the same as before. So an R-squared value can never go down as you add new variables to the model. If you think about it, no variable can be bad enough that it unexplains variability. But in cases like this, it may not really go up. So if we think about this situation, in-state cost doesn't add much new information. It doesn't add much new information to the model that we already had, right? There must be some redundancy there. And if we think about it logically, it's probably between in-state cost and out-of-state cost, right? So in-state cost doesn't add much information when these variables, admittance rate and out-of-state cost, are already in the model. So let's look at the scatter plot matrix to make sense of this a little bit more. So there is a little bit of redundancy between admittance rate and out-of-state costs because we can see there's a slight negative association between those two variables. but there's a lot of redundancy here between out-of-state cost and in-state cost. Right? Those are strongly correlated with each other, and so adding in-state cost into the model doesn't really tell you that much if you already have out-of-state costs, because those are so closely related with each other.